Okay. So when you plug in your little board to your computer, it should show up as a little like USB drive called Circuit Pi. Is that what happened to those of you who are following along? Okay. Now I gave you a few files. Did I not?
Yes.
You should have this Adafruit Circuit Python itsy bitsy m4 blah 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 .uf2.
Yes.
You should have that file. And you should also have the update bootloader itsy bitsy m4 blah 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 .uf2. You should have that. I don't know. I don't know what that stands for. UF2. So because I don't know how, I ordered these boards a long time ago, and they've been sitting there in a box for a while, and this is ultimately, these are just a little computer. We want to make sure that we're running the most recent operating system, okay? And in this case, the operating system is called the bootloader, and it's just the bit of code that sits on it that makes it know that it's a computer, okay? So we need to make sure you're running the most current bootloader. So what you're going to do is you are going to double click the little button on your board. Just click, click. And your computer will probably freak out for a second because it will lose track of it. And it should come back up as itsy m4 boot instead of Circuit Python.
It keeps opening a keyboard setup assistant.
Did you read the thing?
It thinks it's a keyboard.
It
Yeah.
says if it's not a
Okay.
keyboard, you can click quick.
Yeah,
Okay.
just click. It's not a keyboard.
I just,
It did that for me too.
Okay. So it says itsy m4 boot. Did everyone get itsy m4 boot?
Yes.
Yes? Okay. So the first thing we're going to do is update the bootloader. So that's what this is. So we're going to take the update bootloader itsy bitsy m4. All you're going to do is drag that into that location, okay? And it will copy it and then crash.
I didn't get that. It didn't.
Nice. It crashed.
It did disconnect, but it didn't change its name.
Did you double click the button?
Yeah, and it disconnected. It was upset that nothing else happened.
So when I said, did everyone say itsy m4 boot?
I was checking.
Oh, I see.
I didn't have the. Oh, there it is. Now it's
Okay.
okay. It was happy that.
Okay. So if yours, yes.
When I clicked on the thing, it's a zip file or the document for the
Well, that's the Circuit Python one. Where's the other one? Oh, so down there. There, keep going. There you go. That one. Okay.
It says that there's no application.
Yeah, no, I didn't say to open it and cancel. I said to drag it onto the itsy m4 boot thing in Finder. Just like you're copying that file to that itsy m4 boot thing. So everybody watch. Eyes up. Eyes up. Here it is, the itsy m4 boot, and you see these little files, and you're going to take that bootloader file, and you're going to drag it
I think
into there.
we haven't gotten to itsy m4 boot yet. We're still.
I dragged this over to here.
Oh, because it still says Circuit Pi. Okay.
How do I get to it?
You have to you have to double click the button. And then it'll crash.
Oh, yeah. Okay.
There you go. All right. Okay. So once you drag that on there, it'll crash and then come back. And it should still say itsy m4 boot at this point, right? And you should be able to, in this info, it should have this info uf2.txt, and it should say the uf2 bootloader version 3.15.0. If that's what it says, then that means it worked. It successfully updated the operating system. Okay? So does everyone say that?
Yeah.
Does anyone not say that? 3.15.0. That's what I sent you. Okay. All right. So if everyone says that, now this little computer can be programmed using a few different, programming languages.
Like what?
Well, we're going to do Circuit Python, which is a subset of Python. Or you can do Arduino. It'll run Arduino. Those are the two main ones. I think there are a couple other options, but most people just do Arduino or Circuit Python.
My mom is a coder and she never learned Python because the snake on the book scared
Ah.
her.
Well, the good news is Python is easy, so.
She could probably learn it. She
Yeah,
just
I'm
got
sure she
scared
could. Okay, so now what we need to do is tell it, hey, we want you to be a Python board. Okay, so we're going to give it the Python code. Okay, and that's what the other thing is for. So this file that says Adafruit Circuit Python, itsy bitsy M4 Express. So this is the Circuit Python code thing for this particular board that teaches this board how to follow Circuit Python code. Okay? Yes, Sam?
Is that the zip file or the UFT?
The zip file unzips to become a UFT. Okay? So you're looking for this file that says Adafruit Circuit Python itsy bitsy M4 blah 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 8.2.7.uf2. Everybody have that file?
Where are you getting these files? Like off the internet or do you like sit and make them?
No, I did not make them. I got them from the Adafruit website that makes this board. So this is the thing, and so there's a link here that says, oh, here's where you get the files. Here's where, here's where you get everything. Okay, but in the interest of getting us through this today, I gave you all a head start and says, here's the files. So we didn't have
Instead of making us
to,
I thought you were gonna say instead of making you guys redo it.
No.
Yourself.
Okay, so here's what you're going to do. You're going to do the same thing now. This Circuit Python file, you're going to drag that also into there. This time, I don't think it's. Let me try it again. Oh, hang on. Hang on. Oh, I'm getting an error. Why am I getting an error?
So it says it
I did
cannot
not.
be completed because there are more required. I just clicked it down.
Mine turned into the circuit thing.
Yeah, it should. That's how you did it right. Okay, so I'm wondering if. Well, no. You don't drag the zip. It's a sync thing. Like it thinks it's in the cloud. So I'm gonna copy this whole thing to my desktop. It should be CircuitPy now if you've done it right. Okay, so let me try it again. All right, I'm going to eject it and plug it back in and see if I can make it do it. Let's see, M4 boot. Oh, there it goes.
Okay, so just eject and
Yeah.
plug back in.
So I just unplugged the USB and plugged it back in, and then okay. So if you do that, it should come back up as CircuitPy.
Do I need to properly pressing?
Doesn't matter.
I don't have all of them.
Do
Also
it.
just hit the unplug button. It's not gonna hurt it if you hit the eject. You don't know.
Yeah, but I want to power cycle it. And ejecting it doesn't power cycle it.
Ejected it worked for me.
All right. Good?
Okay, it worked for me.
Excellent.
Mine just says the boot out thing in mine though. It doesn't
Yep,
tell us.
that's fine. Totally fine. All right. So, yeah, yours ultimately will probably look something like this now. But I don't know. Do you have a settings
No,
thing?
just the boot.
So I'll get rid of mine too. Great. Perfect. Very good. So let's do some stuff now. You ready? This thing's ready to be programmed. Where is that file?
On my desktop.
Let's find out for sure. somewhere local on your computer.
Who's buying
Right now,
temporary
your
documents?
desktop is not local. Your
For
desktop is
scripted
not
Python.
How do I?
Well, it's only 95 cents.
How much of a nerd do you need to be?
Let's see. So you probably need to. Is your documents
Some people
also
just
in
want to try
iCloud
it
or?
for the program.
Yeah.
Why do you hate?
Oh yeah,
That's the
it
one
is.
that's not.
So go
guess if that's what you
to
want.
Some people just want.
downloads probably will work for now. If you put it there, it's probably work. So copy that. Just copy the file to there.
Like drag and drop it.
Yep.
Move.
Yep. Okay, so now in downloads you should see it. So unzip it, unzip it.
No.
So now open that folder. Oh wait, what? That's not right.
Should I move the whole folder?
Yeah. Let's go back. Okay, so now look for, there it is, that. Yep. Okay, so now that you got locally, now unplug the thing, plug back in.
No. Drag and drop it.
Yes. There it is. Boom, it should come up as Circuit Pi. Hey, yes, okay, so click that. There it is. Okay, excellent. We're good to go. All right, so now hopefully you installed this thing called the MU editor, MU editor. Okay. And yours probably didn't come up like this. Yours probably is saying, what kind of editor do you want to be when you grow up? You want to be a Circuit Python editor. So select Circuit Python.
With the purple snake.
Yes, with the purple snake. Okay. So yeah, you probably have this window, right?
Yeah.
So you can say Circuit Python and click OK. And then you will get this empty thing that says write your code here, smiley face. Okay. You are going to save this to your board.
It's not
Open your what?
telling me to put an application.
Yes, you need to do that.
Yeah, I did.
Oh no, okay. You don't put the drive in applications. Put the application in applications.
Oh, with this thing?
Yeah. Quit that. Okay.
And then just drag it.
Yep.
Oh, great. Okay, great. I'll pick it up.
Okay. So this is very important. This next part. Okay. You are going to save this as code.py. Part of that little CircuitPython operating system that we just installed says, hey computer, when you turn on, if you see a file called code.py, do what it says. Okay? So if you save your instructions into a file called code.py, then those instructions will automatically be followed by the computer every time it turns on. Okay? So you're going to save it as code.py. Py. Okay? So I'm going to hit save, and there it is. Now it's sitting there. And now we get to do some Python. Okay? So we're gonna start just simple. We first need to import some libraries. Libraries are chunks of code that you can use to do stuff. Okay. So the first thing we need to import is something called board. So literally type import space board enter.
And it does it?
Well, I haven't done anything yet.
Oh, okay.
But the board that you just imported, that's like all of the standard instructions and the code samples and stuff that you can use, the code languages, to talk to the board, because you're going to need to do that. Yeah.
Should we leave like the smiley face in or?
You can change that to whatever you want. Just leave the little pound sign on it. So, for example, like in mine, I said QLab remote. And then you could do another line that says by Jason Romney on November 16th, 2023. Yeah. All right. What's that? Yeah, it's called a comment. It's comment code. You comment it out. That anything that starts with that pound sign, the computer will not follow as instructions.
Oh, so it's just like nice little notes.
That's notes to you.
Yeah.
Yeah.
Oh, yeah.
That's notes to yourself.
Who reads the code?
Yeah, for someone who reads the code. It's not those. The computer does not read those. Only humans read those.
Either explain
If
it.
you're writing code for like a project,
Yeah.
and can someone write little notes like, hey, this is wrong, but they would have to do a pound sign first.
Yeah.
Just wondering.
Yeah, it's just a comment. It's just, All right. So we're going to import board so that we can talk to the board. All right. We are also going to just, trust me here, we're going to need this in a minute. We're going to import time. And importing time is basically importing some libraries that allow the computer to tell time or keep track of time or determine how much time has passed or things like that. So somebody's already taught the board how to tell time, so we don't need to do that. All we need to do is import their code, and then we can use it. Okay? So we're going to import board and we're going to import time. And then we're going to use the digital inputs and outputs of our board, right? Because you hooked up the LEDs and the buttons to the inputs, right? So we are going to import, and we're going to just cut to the chase here, okay? Because we don't need everything from digital I/O. So we're going to say from digital I/O, which is another library that teaches, that tells you how to access those input and output pins. So from the digital I/O library, import digital with a capital D, in, out, and it should automatically, once you start typing that, it should give you that as an example, like as hey, is this what you're looking for? And say, yeah, that is what I want. I want digital in, out. And then do a comma, and we also want direction. And direction is, these pins on the board can be input pins or output pins. Depends on what you want them to be. And so direction is the code where you tell the board, hey, this pin's an input, this pin is an output. Okay? The direction that the data is going to go. Okay, so there we go. Now, what I thought we'd do first is let's just see if we can make one of the LEDs turn on. That'd be fun, right? So first thing we're going to do is we are going to say,
Did you want to skip 2 lines?
oh, it doesn't matter.
Okay.
I like to just because it, breaks things up a little bit better for me. So what I'm going to do is let's turn on the green LED. Okay? So to turn on the green LED, I first need to, what I would say, initialize it. So we're going to say, I'm just going to create a little variable called green LED. So I'm going to invent a word, and that word is green LED. Okay? And then I'm going to say green LED equals a digital in out. Okay? So there's this thing that I'm going to call green LED. And what I call green LED, the computer calls a digital in and out, and I'm going to give it a specific thing. So I'm going to say digital in out, and it's going to be board dot A2, because that's what I hooked the LED up to, isn't it? followed my instructions, the green LED should be wired up to A2, right? So green LED is going to equal digital in and out board A2. So this is just me teaching the computer a new word. So I'm going to say this word green LED. And whenever I say green LED, what I mean is pin A2 on the board. Okay? This way I don't have to type digital in and out board A2 every time I want to do it, right? Just makes my life a little easier. And the computer's quite happy to do that. So the next thing I need to do is tell the computer what direction A2 is. Is it an input or is it an output? Right? So I'm going to say green LED direction equals direction with a capital D dot input, all caps. Yep, this is a syntax. Syntax is a term we use in code to just be like, there's a certain way you have to write things.
Grammar.
Yeah, it's grammar for computers. So green LED direction, which when I say green LED dot direction, I'm saying, hey, that thing that I invented called green LED, I want to tell you something about its direction. And the thing I want to tell you is that the direction is actually output, isn't it? Because we want to go out to the LED, right? I did that wrong. So so far I've said import the code that tells you how to talk to the board, import the code that tells you how to do time, and from the library called digital I/O, bring in digital in, out, and direction. So I'm saying, all right, there's this thing I call green LED, and green LED henceforth and forever will be known as digital in and out board A2. And now that we understand that, then let me tell you something about this green LED that is digital in and out board A2. It has a direction, and that direction is output. Okay, so now I can send things out of that pin, and it will be quite happy to do that for me. So now what I'm going to do is just for these instructions will be followed once, and then the computer will stop, unless I tell it to do something different. So what I'm going to do is I'm going to create an infinite loop. And that infinite loop just means just do this forever. Forever. Just do this. And don't worry about it. And the computer's going to be like, fine, whatever. I have nothing better to do. I'll just do what you want me to do. So I do that by saying while true. True is just a little Boolean argument that I'm going to immediately instantiate right now that just says there is this value, and it is true. And as long as that value is true, so when I say while is the way of meaning, for as long as true is true.
Is this like Python's if then?
Yeah, kind of. No, Python has an if then.
Oh, okay.
This is a while loop. This is just like a while
This
a
is
certain condition is, has been met, do this forever.
But how does it know if it's true?
Because I said it is.
Just now?
Just now.
Oh, okay. What? But you didn't write this is true.
I know. This is why Python is great, is because it has all these shortcuts. You don't have to say, I don't have to say, there is a value and it is true. I just say true, and and by just typing the word true, Python knows, okay, there's this thing that he's invented, and he's saying that it's true.
But okay, so say you made green LED, and then you also made red LED underneath it.
Yeah.
If you put while true underneath both of those, would it assume both of those are true, or would it assume
It's not, the true has nothing to do with green LED right now.
Okay.
True is just
Just in general?
it's an arbitrary value that is nothing.
Cool.
It is just true.
That's
It is just the universe.
right.
Basically, while the universe exists is all I'm saying.
Okay.
While the universe exists, do this.
Okay. So while this computer is working, do this.
Yeah.
Okay.
It's like a lawsuit.
Yes.
If true, it's true.
Okay, so here's what I'm going to say. So while the universe exists, what I would like you to do is say, green LED value equals true. And then I'm going to say time dot sleep one. So let me explain what I've just said.
I was gonna say explain.
So what I have said is, okay, while the universe is true, I want you to set the value of the green LED to true. And because I said that the green LED is an output, and it is a digital output, that output can be on or off, or true or false, or whatever, right? So by saying that green LED value is true, I'm saying turn it on.
Turn it on.
Yeah. Okay? And then time sleep just means, and then just like take a break for a second, and then do it again.
So flash.
Well, no, I haven't turned it off yet, but I'm just giving the computer a minute, because otherwise it'll just be going, LED, 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 you know, it's like, you don't have to do it that fast. Just like do it, and then you can like chill for a sec, and then you can do it again. Okay, so I'm going to hit save, and we'll see if this works. Give mine a second to load.
Is it supposed to be blinking?
What's that? Yeah, I'm waiting for mine to load. Oh, there it goes.
Wait, what part did you look?
We made a light come on.
Whoa.
Okay, what if we wanted it to blink? Ubby was saying, how do you make it blink, right?
0, 1, 0, 1, 0, 1.
Well, I could say, okay, sleep 1 second, and then say green LED value equals false. And then sleep for a second. And now it should blink on and off every second. If I save. It has to reboot. Huh?
Wow.
All right, so let's build this out, shall we? Let's make them all blink. So I'm going to copy and paste that, and I'm going to say there's another thing called red LED, and that's going to be a 3. And red LED value equals false here. I'm going to make them alternate. Red LED. This is just for fun. Yeah. True.
Can I
Far and
can I
I'd be like,
fix
why
this
is it?
right now?
Yeah.
How do I like I don't want to eject it. Can I just
It's fine.
unplug it?
It'll be fine. All right. So this should make them blink on and off. Let's see.
Is the red flashing
What are your
light?
classes next semester, Jason?
Like, what classes am I teaching next semester?
No, what are you taking next semester?
Acting.
Oh, look, it's blinking on and off.
Ah.
Red, green, red, green, red,
It's like a
green.
stoplight.
I was literally gonna say that.
Literally made a stoplight earlier.
Yeah. Very good.
Now it's yellow. Stop.
There you go. Okay, so you see how this is done, right? This is how we make LEDs turn on and off.
For the yellow ones, sorry.
Yes.
For the yellow ones, would you do yellow LED 1 and then yellow LED 2, or do they both go with this yellow 4?
It doesn't matter because you're making up the words, so you can call them anything you want.
So we could
As long
literally
as you
label
name
it
the
whatever
right
type
thing.
of
Yeah.
I see.
And then we could put
As long
technically
as
a
you're cooking.
hashtag and then say in it yellow LED.
Yes.
We just want to put yellow.
Yeah. So this whole green LED word, that's a made up word. I made that up. That doesn't mean anything. It only means something because I said it means something,
So
right? So I could put any word I want there as long as I then use it everywhere.
theoretically, I could name them Jeremy.
Yeah.
Okay.
Anything you want.
Just theoretically.
Okay. All right. So that is your little quick Python crash course. Okay. And there's a few things that we can do to clean this up. Like anytime you find yourself copying and pasting code, like I just did, there's always a better way than that. Okay. In programming, there's this concept of elegance. An elegant code is code that, is like the simplest possible version of the instruction that uses the least amount of words and the least amount of code that gets the thing done. Like that's called the most elegant code. And elegant code is fast code. Okay, so you want to find ways to make this work that uses the least amount of words as possible. And anytime you find yourself copying and pasting something, you've just like now doubled something, and that's inefficient. So let me show you now. Now I'm going to do something else. So now I'm going to just skip ahead. This will be the cooking show moment, where yeah. So I'm going to first copy this folder called LIB into here, and I think I gave you a thing called this Adafruit MIDI, I believe. Did I give that to you?
Sounds familiar.
Okay. So you're going to copy that folder into a folder called LIB. LIB is for library. And this is where you can put more libraries that don't automatically come with the CircuitPython operating system. Okay? And the one I want is MIDI. Because we're going to use MIDI input and output to do the QLab. Okay?
That folder already has a bunch of other libraries in it.
For what now?
It's got a lot of.
Oh yeah, you just want the Adafruit MIDI one, is it?
Okay.
That's all you want.
So can I just drag that directly?
Yep.
Okay.
Put it into a folder called LIB. Okay? Then the next thing is I'm going to take this code.py and I'm going to replace it. So this is my finished code.py. And now I'm going to reload it. I'll show you something. Okay, so you're going to make a little folder on your thing called LIB. And inside of that, you're going to drag the folder called Adafruit_MIDI. I gave you a link that downloaded a bunch of Adafruit libraries. And you want to open that up and find the folder that says Adafruit MIDI. And you want to drag that folder into that LIB folder. And that gives you all of these MPY files that let it do MIDI. It's like a Python library file. I don't know what the M stands for though.
Adafruit MPY is the folder.
Mm-hmm. Yeah.
And just put that whole thing.
You want to find the one that says Adafruit MIDI, and drag
Close
that
to
into
the bottom.
Where is it?
So open that folder up. You go to LIB
Oh,
and
It's all the
scroll
way at the
down until
bottom.
you find Adafruit MIDI.
Oh, I think it's the last folder. Second to last folder.
Oh, there it is. Adafruit MIDI.
and bring it into.
Copy that into a folder called LIB on your CircuitPy. Yep. There you go. Now, if you do that, now here is my code for the QLab remote. Now, the first thing you'll notice is all the LEDs are on by default, because we usually do theater in the dark.
What?
And so having the LEDs on is really good, because then in the dark you can see where all the buttons are,
Wow.
right?
Yeah.
So we can do shows in the dark now. Wouldn't that be great? All right, so what I'm going to do, I will give you this file, okay? And you have two choices. I have now taught you just the tiniest little bit of Python, and you should be able to, you could do what I did, which is, hey, yes, you could do what I did, which is hack around for an afternoon and figure out how to do all this by reading all the libraries and stuff like that. Or if you aren't interested in that, that's fine. I don't, you know, you learning Python is not a critical learning outcome for this course, okay? But you can look at my code and try to replicate it yourself to try to understand what I did. I commented everything to explain what I'm trying to do. And you can try to write your own code in your own, you know, using your own variables, like you can call your buttons, you know, Jeremy if you want, or whatever you're going to do. And that's the best way to learn code in my experience, is to look at someone else's code, try to figure out what their code means, and then try to write your own code that does the same thing. And anyway, so let me take you through what I've done. Yes?
I missed the part. Do I put that inadvertently in the, or is it words?
So you're going to make a folder called LIB.
Here?
Yep.
Like create new folder?
Um,
Or I should.
hang
I
on,
don't
why
know.
is that there? That shouldn't be there.
I'm not sure. I didn't.
Yeah, delete that. Yep. You're going to make a folder in there called LIB.
Copy.
New folder. And then, yes, you're going to drop that Adafruit MIDI folder into there, into that folder.
So when you reopen the code.py file, it should.
No, because I haven't given this to you yet.
Okay, I was confused.
Yes. I will give this to you, but I'm not going to give it to you right now, because I wanted to get, I was expecting some of the shenanigans that we've experienced already today, of wiring issues and where are my files on my computer and all that. So I didn't want to jump straight to the end at the beginning, because now that just seeing, hey, can we make an LED turn on? That helped us see where all of our issues were. Okay. So now that we know where all the issues are, and those of you that have issues, you now know what to do about them. Now I can skip to the end and said, here's how you do the QLab remote. So I'm just going to like talk you through this code, and then I'm going to give you the file, and then you can do whatever you want with it. You can just take it and use it if you want, or if you would like to learn the Python and figure out what I did, you can go through it and you can type it yourself, and that'd be totally fine. Either way, it's fine with me. I'm not going to grade you on your Python code. Okay? This is an electronics course, not a coding course. Okay?
Will there ever be a coding course?
Well, my applied digital projects class that I don't really get to teach anymore, we do some coding in there, but anyway, so no. All right, so here's what I'm doing. You already know about importing board, you already know about importing time, and you already know about importing these things from digital I/O. I'm adding one more thing called pull. Pull, P-U-L-L, pull. Pull is the way that we for the buttons. When you set those as inputs, the board needs to understand pulling up or down is basically the difference between being a normally open or normally closed switch. Okay. Normally open meaning when you're not pushing the button, the circuit is not complete. And the circuit is closed or complete when you push the button. Normally closed would mean you're not touching the button and the circuit is complete, and the circuit breaks when you push the button. Ours are normally open. Okay? So the pull up or down is the way we tell the board what kind of button we have. It's either up or down. Okay? So I need pull so I can use the buttons. I'm also importing a generic library called USB MIDI. And that comes with CircuitPython. USB MIDI is part of that. So I'm just pulling in USB MIDI, but then I'm also importing the Adafruit MIDI, because the Adafruit MIDI gives me the libraries to actually send MIDI commands, which is what I need. Okay? And then I'm also importing from Adafruit MIDI this very, very specific thing called systems exclusive, because we are going to use MIDI show control for our QLab remotes.
MSC.
MSC.
I've seen that
Yes. QLab responds to MIDI show control by default. You don't have to do anything. It just automatically responds to that. And it will respond to that even if QLab is not the active application. Yeah. So there are lots of different ways to make QLab remotes, okay? And you can even buy QLab remotes and stuff. And you'll find things online of here's how to make one. Most of them basically involve creating a little box like this that pretends to be a keyboard. And so when you push the green button, it does a space bar. When you push the red button, it does an escape key, you know, just like you would if you're really doing QLab. Well, that's all fine and good if QLab is the active application. But what if, for some reason, QLab goes to the background and a different application pulls up? Like, I don't know, something, yeah, Theater Mix or anything else that you would have running on the computer. Well, then suddenly your QLab remote isn't controlling QLab anymore, it's controlling whatever is the active application. Whereas if you do it with MIDI show control, then it's always going to get to QLab, no matter where QLab is in the hierarchy of things on your computer. And MIDI show control is a subset of systems exclusive. Systems exclusive is a subset of MIDI. It's a manufacturer-specific MIDI messages that we're going to do. Okay, so I'm importing that too. Now here's the next thing I'm going to do. This is to help my code be a little more elegant. So instead of creating a word for every single input and every single output, I'm going to use what are called arrays. Okay?
We have those on As Like It.
Yeah. In this case, it's a code array. So I'm going to create first an array of values that I'm going to call buttons. So my button pins and my LED pins. So my button pins, and I put this in brackets, are board D7, board D9, board D10, and board D11. Those are my button pins. Those are the pins that my buttons are wired up to, okay? And that your buttons are wired up to if you followed my thing, okay? And then I'm going to have another list of LEDs, and these are just the pins that are my LEDs. A2, A3, A4, A5, okay? So that's what I'm just defining which pins I'm using, and I'm sticking those into a little list, okay? And now I'm going to create an array to store the actual inputs, because I'm going to turn the pins into inputs and outputs. I need to store those input and output objects into a different array, okay? So I'm going to create a buttons array and an LED array, and I'm going to do those two brackets, and that just means I'm making the array, but I'm not putting anything in it yet. Because I don't have anything to put in it yet, because I haven't turned those pins into inputs and outputs yet. All I've done is say that they exist. Okay? So now I'm going to initialize the button inputs. So this is a loop for button in buttons. What does that mean? Well, the button is just a word I made up. It could be anything. Okay? So for every thing that I will call a button, that is in the list of buttons. And it turns out there's 4 things in there. So for every of the 4 things, and I'm going to call each of the 4 things a button. So for every button that is in the list of buttons, do this. I'm going to create a new word temporarily that's called a pin. And that pin is called a digital in and out. And instead of just putting board D7, I just put button, because it's pulling this out of that list. I can just stick it in there. So it's for the first pass through, it's going to do it for the first thing in the list, which is D7. Okay, that's the first little pin in my list. So I'm saying for the first one, do all these things. It's going to equal digital in and out. For that pin is going to equal a digital out. The direction is going to be input. I'm going to say its pull is going to be up, meaning it's normally open. Okay, it's normally open button. Okay, great. And then now that we know that it's an input and we know what it does, we're going to stick it into the buttons array. So we can say buttons array append using this pin that we just made. And it's going to stick that in there, and now it's in there. And it's going to do that 4 times. So it's going to create 4 different entries into this array that contain the 4 button definitions that now we know are buttons that are now normally open, and the button is up, and we know that that works.
It's doing it 4 times on like the maybe array.
It's because I made this loop. So for every thing that is in the list of buttons,
Oh, okay.
do this.
It's gonna, so in theory, if you added more to the array,
It's going to keep doing it. Yep. I could add, if I decide I wanted more buttons on this thing, I could just add those to the list, and it would still do it. Yep. And then I do the same thing for the LEDs. So for every one of the things in the list of LEDs, do this information where we turn that into, it's an in and out, it's an output, and we set the value to true so that it turns on the light. That's what we just did, right? And then I append that into the LEDs array. Okay? So there we go. Now I've got a list of buttons and I've got a list of LEDs, and they work and they're ready to go. Now I can use them for things. Now I'm going to create the MIDI output. So I'm going to create this thing called USB MIDI, and it is going to be an Adafruit MIDI port. And if you look up how this works, this is the syntax for this. So Adafruit MIDI, using a MIDI output, using the USB MIDI port 1, channel 0, because MIDI can have 16 channels, but it's 0 based. So it's 0 through 15. Okay? So I'm going to use 0. Turns out the channel doesn't matter for us because we're using systems exclusive messages, and systems exclusive messages don't use MIDI channels. So it doesn't really matter what channel you put in here because we're not going to use it. But you have to put something or it won't make the MIDI port. Okay? So this makes the MIDI port. Now the next thing I'm going to do is I'm going to create a variable called MSC. And MSC is just, the way that systems exclusive works is every manufacturer that makes MIDI equipment has a MIDI systems exclusive manufacturer ID. And it's just a list of 3 numbers that uniquely identifies them as, this is special messages for Akai samplers. This is special messages for Roland keyboards. This is special messages for whatever, right? So MIDI show control is just pretending to be another manufacturer, okay? And the ID number for that is this, 127.127.2, okay? I can show you where to look that up if you'd like to know where that information is. I can show that to you. Or you can just trust me that that's what it is, okay? So that's the first part of a MIDI show control message, has to have those 3 numbers so that it knows that it's targeting any device that is a MIDI show control device. And then I'm going to set up my 4 commands. So there are 4 MIDI show control commands that QLab will QLab will respond to lots of MIDI show control commands. The 4 that I care about are go, panic, forward, and backward, because those are the things I want to be able to do in QLab. So MIDI show control go command is those 4 numbers together, 16, 1, 0, 0. That is just go on the current cue. Yes?
I noticed that all of them have 16, like the 16 kind of like the color and number.
Yeah, so 16 is what's called the command format. And that's a part of systems exclusive. That number 16 is command format, which is part of the syntax for a MIDI show control message. Okay?
So if you were to have another like command that wasn't the boy the choice thing, if there was one that was like, I don't know, up or down, it would start with 16 and then another number.
Well, what they did is they were trying to build in the ability to grow MIDI show control in the future beyond what they imagined the first time around. So command format is just like, well, this will be the first list of the first kind of set of commands that we can imagine MIDI show control doing, and they will all contain this header of 16. And then later, if we decide that there's other things we want MIDI show control to be able to do, we can create a second command format. And we could now go to 17, and now we can create all new commands in there. But they never did that. So, because they basically got it right the first time. And so we haven't really thought of anything more that we need it to do. And so that command format has turned out to be not useful. It's just this extra number you have to add to make it work, you know.
And are these also on a website somewhere?
Yes. So go is MIDI show control command number 1. Panic is MIDI show control command number 8. Forward, which is like go to the next queue, is MIDI show control command number 18. And backward is MIDI show control command number 18. Okay? That's just what that is. And then the extra zeros here is go can include a queue number. So you can say go on this specific queue. And so if you had that, you would add different numbers here. But because we just want it to go on whatever the current queue is in QLab, I'm just going to put zeros. So it's like, don't worry about it. Don't worry about queue number. Just go on whatever is currently selected.
But you can't forward and backward on this particular queue number? Like that?
Forward and backward is just about where you are in the list. So it's like, wherever you are, just go backward 1. Or wherever you are, just go forward 1.
Is there a thing where you can just like jump to a queue?
Yeah, go to queue, whatever. Yes, that's absolutely MIDI show control. Yeah, without triggering.
Yeah.
Okay, so I'm just setting those up. I'm just saying this thing that I'm going to call go is actually these list of numbers, and this thing that I'm going to call panic is actually these list of numbers, right? And just so that I don't have to type those numbers over and over again. And then I'm going to put all of those into an array called commands. So now there's this thing called commands, and the commands are a list. I've got a go, I've got a panic, I've got a forward and a backward. This way I can just say commands.1, and I'll get a go. Commands.2, and I'll get a panic. Commands.3, and I'll get a forward, so on and so forth. All right, so now here's my while the universe is true loop. Here's what we're going to do. I'm going to check each button. So for each of the buttons in the buttons array, I want you to do the following set of instructions. So for the first button, it's going to check the green button first. If the button does not have a value, which basically, this is weird, but that means that the button is pushed.
If it does not have a value, it means it is pushed?
Yes.
Why?
I have no idea.
Okay.
I agree it doesn't make sense. And yet that is how it is done. Yes.
Just to reiterate, the stuff in the hashtags, you don't have to have
No.
these like little notes of
These are my notes to myself. Okay? So check each button. That says 4 buttons and buttons array. That's my way of saying check each button. Okay? Is the button grounded? Meaning, like, is it connected to ground? Because that's what happens. Because you wired the buttons across the pin and ground, right? Which means if you push the button, you're connecting that pin to ground. So is the button grounded? And the way I ask that is, does the button not have a value? Okay? So if the button is pushed, then I want you to go ahead and create this thing called I, which is just, let's figure out what button we're talking about here. And it's the current one in the loop that we're in. Okay? Because I said, just for every button, do this. And it's like, oh, one of them is pressed. Okay, which one? Which one are we talking about right now? So I'm doing buttons array index button. I'm just saying, let's put a number on it. Which one are we talking about? Which one's pushed? And we're going to call that one I. And so now I'm going to say, okay, which command goes with that button? Because it's going to say, oh, the green button is pushed. I'll say, okay, well, which command goes with the green button? So I'm going to say, well, the command equals commands I, because I've got this list of commands, right? And I've got button 1, 2, 3, 4. So it's like, okay, if button 1 is pushed, then go and get the go command and stick that in here. Okay? So great. Now I have the right command for that button. And now I'm going to say, all right, let's send that command out as a MIDI message. So USB MIDI send a systems exclusive message that contains the MIDI show control header, which was this, followed by the command that goes with that button, which is go, if it's the green button. And it'll send that out as a MIDI message, and then it will turn off the LED. Exactly. So I'm saying send the message, and when you've sent the message, turn off the LED that goes with that button. And that's how you know you really pushed the button and the command was actually pressed. So if QLab doesn't do what you want it to do, you should look down and see if the light is off. And if the light is off, that means that it probably sent the message, or at least it thinks it did. Okay? And then I have this thing that says don't do anything until the button's released. So just like stop. So I'm saying while not button value, in other words, while the button is pressed, still pass. And pass just means just don't do anything. Just don't do anything else. Just wait. Just wait until we let go of the button. Because if you don't do that, then it's just going to keep sending that message over and over and over again.
You're going to go through your entire show in a second.
Yeah, literally. You're going to go through all 300 cues in your show in 1 second. Because it's just going to go, I did it, and then it's going to like do the loop again. Like, oh, you're still pushing the button. All right, I'll send it again. I'll send it again. I'll send it again. I'll send it again. I'll keep going until all of your cues fire all in one big thing. Stage manager says go, and the whole show happens all at one time. Okay? Yeah, and then exactly. So for as long as you have that button pushed, it's just going to keep sending go, 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 go. We don't want it to do that. We're saying no. Do it once, and then wait. Yeah, just stop. Don't do anything else until I let go of the button. And then you can continue scouring the chip to find out what buttons are pushing, right? But as long as I got one pushed, just like don't do anything. What this means is you're not going to be able to do 2 buttons at a time, right? And why would you, right? You would never want to be able to press go and panic at the same time and have both those things happen, right? You would never want to have forward and backward happen at the same time, right? You would never do that, right? So we are building in the ability to only have one button able to function at any single time, okay? Because when you push one button, it's going to stop. It's going to do whatever that button's supposed to do, and then it's just going to wait until you let go. So it's not going to be possible for a double tap, right? Or, or a string of things, or for 2 things to happen at once. It's just like one thing's going to happen. So we're saying, while it's pressed, just wait. Pass is the word we say. And then, turn the LED back on when the button is released. So it's going to wait until I release the button. And once it realizes that I've let go of the button, then it's going to go and look for the next instruction. The next instruction is turn the light back on. Turn the light back on so I know that the button isn't pressed anymore. Okay? And then I have a little sleep of like 1/100th of a second. To just be like,
Does the computer actually use that?
yeah,
Does it help?
yes.
Oh.
Because if you don't do that, it's going to move so fast that sometimes it'll miss things. It's like just moving so freaking fast that things won't always work. And so I just do that I found that if I just do that little sleep at the end of that while loop, just like, okay, it's okay. Now this is like your breath mark on the music score. This is where you can take a breath. Okay, now go through the whole thing again. Okay.
The 100th of a second isn't enough. Like if I accidentally hit go and need to panic quick, that's not enough time for me to notice it delay.
Shouldn't be. If you are, for some reason, if you are that fast, then yeah, you can shorten that. You can make that time. You just need to give it a little. This is letting the computer know when it can breathe. Right? It needs to breathe every once in a while. Just be like, okay, and now you can breathe. Just for 1/100th of a second, and then like continue. Now, let's see what happens now. This is my little program called MIDI Monitor. And this just shows you MIDI messages that come in on the computer. Now look, it sees that's itsy bitsy M4 Express. If I push the green button, I get this message. Now this is in hexadecimal, not decimal. Do you know what hexadecimal is? I'll teach you that in the sound design technology class. It's just a different way of counting numbers. It's a base 16 instead of base So this is that list of numbers. So this is the 127, 127, 2, right? So 7F is 127. 7F is 127. 2, this is the 16. That's the 1. That's the 0. That's the 0. The F0 and the F7 are the things that go before and after systems exclusive messages. So that's a valid systems exclusive message. It worked. And I hit the stop button, and there's that one. I get command 8, which is stop. Go back. I get command 11, which is back. I get forward. I get command 12. Okay? So it works. Let's open QLab and see if it wants to do it. Oh, where are you? All the way down here. Let's see. Do I have a QLab file in here anywhere? I don't know if I do. Hang on. I need to get my hard drive out.
Americans love talking.
What time is the dress rehearsal?
I don't know.
How dare you ask?
Yeah. The best Christmas pageant ever. The musical.
Would you say it's good, Jason?
Oh, it's great.
Would it fall under the best Christmas pageant ever? Whatever you said it was called?
The musical.
High School Musical, the musical show.
Yeah. Okay, I'm just going to make a new one real quick. Okay, so here we go. I'm just going to make a bunch of dummy cues here. Okay, there they are. Go, go, go. Back, back. Oh, there, hang on. I got them backwards.
Well, if you flip it upside down, you're not backwards.
I'm going to just switch the code. I'm going to put D11 here and D10 here. That's way easier than resoldering it, because I probably soldered it backwards.
If you follow it to Google, is it also set up backwards?
No, it should be all right. Okay, come on. Oh, there it goes. Okay. Hey, there we go. There's nothing to panic, but it should work. I can make something happen. Let's see.
Is that your computer's name?
Richard, yes.
There has to be a reason.
Because I name all my computers after Shakespeare characters. This is King Richard. Because I do. You have to name him something.
Well, I just thought you had like some type of like.
What do you name your computer?
My computer's name is
Ace.
also Richard,
Oh.
but it's named after Friends characters.
Ah.
Friends?
Yeah.
Richard and Friends. Oh, the doctor.
Yeah.
Okay, there you go. Telephone ringing, telephone ringing. Okay.
Oh, it does an emergency stop, not a fade stop.
Yeah.
Okay, nice.
Can you make it a face stop?
I don't know, maybe. I don't like the fade stops.
Yeah.
What if you put a fade stop in and it goes?
Let's see. MIDI show control. I might have mine set to not do that, actually. Panic duration is oh, no, it should fade. Well, it's because MIDI show control it doesn't, but I don't care. I like that. Anyway, so there you go. Now, there is one last thing that you may want to do, which is that if you look here, my QLab remote is still showing up as a USB drive, which maybe would not be the best idea. Yeah. I mean, actually, if it's ejected, it doesn't matter. Like, it'll still work. Okay? But that could be confusing. Like, let's say you're going to sell this to somebody. And they're going to be like, what is this weird thing that shows up on my desktop when, and they can add, then they can see your code. They could like,
Steal it.
well, they could alter it or, you know, break it or whatever, right? so what we're going to do is there's another little thing built into this called boot.py. And when this thing turns on, it first looks to see if there's something called boot.py. And if there is not, then it looks for code.py and does that. But if it sees boot.py, it does those instructions first. And then it will do the code.py instructions. So what I'm doing is I have boot.py. I'm doing two things here. First of all, I am importing these libraries: storage, board, digital I/O, and USB. HID, human input device, that makes it not show up as a keyboard. Okay? Because that's the other thing that'll happen. Is sometimes people plug this in. It's like, hey, you just plugged the keyboard in. Like, no, I didn't. Okay? So what I'm going to do is I'm first going to create a button, which is going to be my red button. And in this case, if it's basically going to check if button value, that means it's not pushed, right? Because it's the not value that is when it's pushed. Okay? So I'm saying if the button is not pushed, then disable the USB drive and disable the keyboard.
Oh, so if you plug it in and you hold the red button forever and ever, then it won't work. But if you
So yes, what'll happen is if you might want to change your code sometime. Maybe you think of another thing you want to make this thing do. You want to get access to that code. So that means when you plug it in, if you're holding down the red button, then it won't disable the USB drive or the keyboard. So that's your way of getting access to your code. Okay? It's the back door, right? So what I'm going to do is I'm going to take this now, and I'm going to copy this also to my thing. Let's see. Oh no, it's here. Oh no, I already ejected it. That's why. Okay. Yes, I don't need that anymore. Okay, there it is, CircuitPy. So I'm going to take this boot.py. I'm going to copy that as well. There it goes. And now I'm going to unplug this. I'm going to plug it back in. And it comes up with the lights, but it didn't pull up. Oh, it did pull up. Why did it do that? Boot.py. Oh, it's empty. Okay. Let me try that again. Replace. Okay, there we go. Now let me eject that. And I will now unplug. And I will plug it back in. Okay, now it doesn't come up, but it should, the QLab part should still work. Yes. Okay. Okay, so it still works, but it doesn't pull up that USB drive, and it doesn't look like a keyboard when I plug it in. But if I ever want to get access to the code, I just unplug it, I hold down the red button, and I plug it back in again, and now I can get to the code. Yes.
I don't see the boot.py.
You have to make that.
Where do you boot it?
You just save it and type the code.
Are you gonna put that?
Yes, I'm going to give you these two Python files, okay? And if you would like to interrogate them and try to understand what I have done, you should do that, okay? And maybe even write your own version of this code that uses different words and stuff. If you would like to do that, you may. But if you would like to not do that, and that's just not something you're interested in, it's not part of this class. This is not a coding class. This is an electronics class. But if you would like to learn this, you can dig through it. I've commented it all out. I've explained what it means. You can look up these libraries. You can figure out what it's doing, and you can go there. Or you can just take these and copy them onto your thing, and it'll work. If you've soldered it the same way that I did. Okay?
Did you color code them, or did it do that automatically?
Did I what?
Color code them.
That's just happening automatically. The Mac does that
That's so fun.
because it recognizes that it's a Python thing. Okay. There you go. Now I'll stop recording.